Let's look at question number 6 of the 2025 AP Calculus AB exam. This was only on the AB exam. This is not a shared question. I have not read the question yet. All I have done is looked at the questions closely enough to know what was common to both AB and BCs. So you get to watch me solve this in real time without a nice, polished, rehearsed presentation. So if I make mistakes, which I very well may, make sure you point them out in the comments. And if you like this, go ahead and hit that like button, because my students never do. They hate me. Let's look at this one. So consider the G defined by, consider the G, curve G defined, okay, implicit differentiation. First question is a proof by on a technicality. They give you the answer. We just have, not a technicality, it's just outright a proof. But anytime they give you the answer to a question and you have to show why the answer is what it is, that's a proof. And so they tell you what dy dx is. We need to go through the calculus to show that that is indeed the correct derivative. So if I differentiate that, the derivative of y cubed is 3y squared, but that is not an x. So I give it the implicit treatment times dy dx. Same thing for the derivative of y squared, and the derivative of y is also dy dx. The derivative of 1/4 x squared is 1/2 x. And the derivative of 6 is 0. And so we're going to do this. I'm trying to look at what their answer. Oh my gosh, what did they do? Yeah, that's right. Wait, what? Okay, I'll just keep working. I think did I copy the question correctly? Yeah. Okay, so I'm going to factor the dy dx out. Whoops, times 3y squared minus 2y minus 1. I will move that 1/2 x over, so 6 minus x over 2. Okay. All over, no. And then we'll divide the whole thing by the 3y squared. Actually, I'm not going to write it that way. Okay, so then dy dx will equal. Now, here's where I was kind of hesitating earlier. I would like to write this as just 6 minus x over 2, all divided by that expression, but I need my answer to look like their answer, and they don't have a fraction in the numerator. So I think I'm going to combine 6 minus x over 2 as with a common denominator, and 6 minus x over 2 would be, that'd be 3 times 3, that'd be 6 minus 3x over 6. So that's 6 minus 3x over 6. And so, what am I doing here? No, don't do that. You know what? I'm thinking too much. I'm just going to go ahead and do this as I want it to be. Oh, the derivative of 6 is 0. There's my problem. I'm such a dingbat. Okay, never mind. This just got a lot easier. I'm sure you'll like scream at me, the derivative of 6 is not 6, you dummy. All right, so we have negative x over 2, and I'm also going to divide by, okay, that was nice. Holy cow. Holy cow. There we go. And that's exactly what they said it should be, so voila. All right, number B, there's a point P with x coordinate of 1.6. Use the line tangent to the curve at 2, -1 to linear approximation. So we need the line tangent. So my point is 2, -1. My slope is going to be the derivative. I'll write the word slope. The slope is the derivative, dy dx, such that my coordinates xy are 2, -1. And that would be, and my derivative is negative x, I'll be positive 1 over 2 times 3 times 2 squared minus 2 times 2 minus 1. And I generally don't clean things up, but I'm going to use this in a tangent line. So I'm going to simplify that. So that's 1 over 2 times, see, that's 12 minus 5, 2 times 6. Is that 14? 1 over 14? I think that's right. 12 minus 4 is 8, minus 1 is 7, times 2 is 14. Okay, so there's my slope, 14, and then my tangent line is going to be y minus, and I'm going to go ahead and move that 1 over. It's going to be the slope of 1/14. Just leave it on my desk, please, ma'am, or on your desk, or whatever. That'd be 1/14 of x minus 2. I'm going to go ahead and move that 1 over, and then we are approximating the y coordinate when x is 1.6. See as though my y coordinate at 1.6, when x is 1.6, will be approximately 1/14 of 1.6 minus 2 plus 1, and I just don't care what that equals. So there's my answer for number B. Number C, for all positive x's and y's, there's a point S on the curve at which the tangent is vertical. Find the y coordinate of point S and show the work. So for a vertical tangent, you need your derivative, your slope, to be undefined. So vertical tangent is when the slope is undefined. My wife is calling me, so let me pause this and I'll finish this in a minute. Okay, so back to this one. We're talking about vertical tangent lines, and that will be when the derivative is undefined. So dy dx is undefined when its denominator will equal 0, which will happen when the expression 3y squared minus 2y minus 1 is equal to 0. We're going to factor that guy. 3y, y. Factors of 1 are 1 and 1. That's pretty convenient. And I need a negative 2, so I'll be plus 1, minus 1. That's going to happen when y equals negative 1/3 and y is equal to 1. Now, they said find the, okay, so they do specify the x and y are positive, so we will discard the negative 1 and leave y equals 1 as our point where the derivative is undefined, which will give you the vertical tangent. Find the y coordinate of the point S and show the work. We're done. Number D, last one. Woohoo! A particle moves along the curve H, defined by the equation that at the instant when the particle is at the point this. We have that and that. This is a related rates question, and this is typically how they've done related rates. They just kind of squeeze it at the end of another question, and quite honestly, this is a very convenient related rates problem because they outright give you the equation, and they tell you that x is 4, that we're looking at the point 4, 1. So x is 4, y is 1, dx dt is 3, and we're looking for dy dt. And so let's differentiate this. We have a product rule. I'm going to group this as 2x for the first term and then y for the second one. The derivative of 2x is 2, but the derivative of x, we're differentiating with respect to t, so that's going to be 2 dx dt. I almost forgot that. Times y plus 2x times the derivative of y, which would be dy dt, plus the derivative of natural log y is 1 over y dy dt is equal to the derivative of 8, which is 0. And now we will start substituting all of my values. So we have 2 times dx dt, which is 3, times y, which is 1, plus 2 times x, which is 4, dy dt is unknown, plus 1 over y, which would be 1 over 1, that's 1, dy dt equals 0, and we'll solve that. That's 8 plus 1, that's 9, dy dt is equal to negative 6, and I'm getting dy dt to be negative 2/3. dy dt is negative 6 over 9. That does reduce to negative 2/3, but we don't need to simplify that. And I think I'm done. That is all of the AB questions. Yeehaw, we're done. And I'm about to start working on the BCs. If there are any mistakes, let me know. Thank you very much.